Today is November 21st, 2011. We're on lesson 6.1. Now this lesson is called Maxima and Minima. The idea to this is what we're going to be doing is completing the square. We've written that down as our objective for this lesson. We're going to be completing the square. The major formulas you need to know: standard form, vertex form, and this formula here, creating the perfect square trinomial. This is a little side calculation we're going to be working with. I put two of them just so I can grab one and move it to the other side quickly. Okay? Now, very first thing we need to talk about, okay, we're going to be taking our standard form of an equation, and we're going to be changing it to vertex form. Okay? And in that process, we'll use this little perfect square trinomial, or perfect square, creating a perfect square trinomial. It'll be part of the process. But today what we're going to be doing is we're going to be going from standard form to vertex form. The reason we'll do that is because looking at an equation in standard form, I couldn't quite tell you where the vertex of an equation is. But if I go through rearranging the equation into vertex form, we instantly know what our vertex is. We know that our vertex will be the opposite of our h value and our k. Okay? So if this is, and when I say opposite of the h value, I'm including the sign in front. So if it's -2, then our vertex is -2, which gives us a +2. Okay? This is very important today. Also, for maxima and minima, they're talking about the max or min of an equation. What they're talking about is the k value of the vertex. Depending which way a parabola opens, so we have a parabola that opens upwards, or we have one that opens downwards. This, I should have rearranged those. Okay. This will be the maximum point of the parabola. That will be the minimum point. So essentially, our k value will tell us what the max and the min will be to a parabola. Those are all very important for today's lesson. We're going to go through the process now. Okay, so our very first example, we have an equation here, x squared plus 8x plus 5. We need to recognize that we are in standard form right now. This is our standard form to the equation. We have our a value, our b value, and our c value. Okay. Now, when we first go through this, what we're actually going to be doing is we're going to be separating the a x squared and bx from the c. I'm going to be working with just these two brackets to start when I'm working on completing the square. The reason for that is I'm going to divide the first two numbers. So in this case, we're dividing these first two numbers by whatever our a value is. Now in this case, what is our a value? 1. Okay. Now I'm going to divide both of these by 1. 1 will become our common term on the outside. So I have 1 on the outside of the brackets. What goes inside those two brackets? Squared plus 8x. Did 1 change anything? No, it didn't change anything. That's okay, because I want you to get used to this process. Anytime it does not have the value of 1, you will have to divide by whatever a is, both of the first two terms. Okay? That's part of this process. Now that we've done that, we're going to be doing a little side calculation. I want you to consider this value, the 8, our new b value. Now, it hasn't changed once again from what our original b value is, but if a is a number other than 1, this new number in the brackets is going to be referring to this equation we're talking about here. That's where we're going to start using our side calculation. So, I'm going to put a little line here. The reason we use this side calculation is the whole goal to this is we're trying to create a perfect square trinomial. Okay? So our b value is our 8. So we're going to get equals 8 divided by 2 squared. 8 divided by 2 is 4. Squared is 16. Now, this number is important because we're actually going to be adding and subtracting 16 into those brackets. Now let's quickly talk about, if I have an equation and I decide to add 16 and subtract 16, what am I doing to the equation? What am I putting in there? 0. I'm putting absolutely nothing in, so I'm not changing the equation. The reason we're doing that is because we're trying to set up a perfect square trinomial, which is exactly why our definition is that. So, our very next step here is in those brackets, we're going to add and subtract 16. Since that was our number, we add 16 and subtract 16 to the equation, plus 5. Okay. Now, the one that's important for our perfect square trinomial is the positive value. I need that positive 16. It needs to stay in the brackets. The negative 16 actually needs to come outside of the brackets. It needs to go outside. And when it goes outside, it actually has to be multiplied by this term in front of the brackets. So I have to multiply it by my common term, which is 1. Is it going to change negative 16 when it comes outside those brackets? No. So when I bring the negative 16 out, I have 1 times x squared plus 8x plus 16. Negative 16 times 1 is negative 16, so negative 16 plus 5. I'm going to quickly just collect like terms outside of the brackets. Does this 1 need to be there in front of those brackets? It doesn't really. The reason I did that is because I just want you to get used to the process. X squared plus 8x plus 16. 16 minus 5, or negative 16 plus 5, sorry. Negative 11. Now, what we've done here is we've created a perfect square trinomial. Right? And actually, so if you guys notice, I added a formula here. This is a perfect square trinomial. What's important about a perfect square trinomial is that we can factor it very easily. Okay? Essentially, we can factor it into one bracket. And that one bracket is the bracket I'm talking about here in our vertex form. It'll be the exact same bracket by itself. So, I will show you on another page how to factor this the normal way, and then we're going to talk about factoring it the quick way. So we're going to use this factoring as a side calculation, okay guys? So I'm going to do it here. So if I had to factor those brackets, and I'm just talking about the x squared plus 8x plus 16, I'm going to quickly factor it on the side. X squared plus 8x plus 16. Let's do it in another color. So we're factoring this now. Factors of x are 1x and 1x. 16 are 1 and 16, 4 and 4. We know that their products have to add up to 8x. What am I going to be using? 4 and 4. 1x times 4 is 4x. 1x times 4 is 4x. So these are the two columns we're using. We go to put them into brackets. Our first terms are x and x. And our second terms are positive 4 and positive 4. This can be represented as x plus 4 squared. Every time we do this, where we use this little formula above, our b divided by 2 squared, plug it into the brackets, then take the negative out, we're creating a perfect square trinomial. So we're actually always going to get an answer that will be the same bracket times itself. And instead of factoring it this way, there's a much faster thing we can do here. Okay? What we're going to do, we're going to continue down on the question. We already know what the factored form of that's going to be, but I'm going to show you the shortcut for this. x squared plus 8x plus 16 minus 11. Now, in order to factor this, all I have to really do is find the square root of the first term, square root of the last term. They're going to be combined into one bracket. We'll square root our first term. Not sure what happened there.
So is that -1 or -11?
Oh, it should be -11, you're right. We're finding the square root of x squared is going to be x. And the square root of 16 is going to be 4. Those are the two terms that turned out to be in our single bracket when we factored it. So I find the square root of our first term, which is x, and I put it in. The square root of our last term is 4. I put it in. I take whatever sign is in front of our b. So because I have a positive sign, I'm going to put a positive number or positive operation in there. I put the squared on the outside of the brackets, and I bring down the -11. And if you guys look, we are now in vertex form. Okay? Our a value is 1. Our h value is our +4. And our k value is -11. So the vertex of this is -4, -11. Now there's one other thing I want to tie this to. When we're graphing this, first of all, a is what in this equation? Positive or negative? Since a is +1, we have a parabola that opens which way? Up. Opens upwards because it's positive. So because it's positive, our vertex is at the bottom. It has a minima, or it's a minimum value. The minimum value is -11. This parabola will never go lower than -11. Okay, example 2. We start off in our standard form, like we said we would. Let's move that. We're in our standard form, but this time I want you guys to notice our a value is not what it was before. So, like we said before, we need to find the common factor of the first, or sorry, not the common factor, but we need to divide the first two terms by our a value. Our a value is the number 2, so we're going to divide both of these by 2. That number comes to the outside, so we now have 2 on the outside, x squared plus 6x plus 11. We now have a new b value. Our new b value is that number 6. This is where we use our equation creating the perfect square trinomial. We use this equation. We take our b, which is 6. 6 divided by 2 squared. 6 divided by 2 is 3. Squared is 9. So we need to add and subtract the number 9 inside those brackets. We're going to get 2x squared plus 6x. And remember, we add and subtract 9. Add 9 and subtract 9 plus 11. The one we want to keep inside the brackets is the +9. So I'm going to be moving -9 outside of the brackets. When I move -9 outside the brackets, I have to multiply by the term in front. So I multiply by the number 2. Our next line will read 2x squared plus 6x plus 9. When -9 moves outside the brackets, we get -18 plus 11. We're going to simplify our last two terms. Plus 6x plus 9 minus 7. And this is where we can use that shortcut I talked about. Now remember, I'm going to be factoring this trinomial here. And in fact, it is actually a perfect square trinomial. Okay, so like we said, we created a perfect square trinomial, which means now, to factor it quickly, I can just square root the first and last terms. When we find the square roots of those two numbers, we'll do it on the side here. Square root of x squared is just x. Square root of 9 is 3. So that is our first and second term in the brackets. We combine it to just one bracket squared. We know the two brackets are going to be the exact same. And we get x and 3. And because 6 is positive, we bring the positive sign down. Minus 7. So now what we've done, I want you to connect this now. We're now in our vertex form. We have our a value, which is 2. So we know this is going to be stretched. We have our h value, which is positive 3. So the vertex is moved 3 to the left. And our k value is negative 7. Because a is positive, we have a parabola that's going upwards, which means, again, we have a minimum value. And the minimum value is whatever k is. So it'll be negative 7. That's the lowest this parabola will go. It will always go higher than that. And let's just prove it. We're going to plug in the standard form into our graphing calculator to see if we would get that proper parabola that would have a vertex at negative 3 and negative 7 and stretched by a factor of 2. We're going to plug factor of 2. We're going to plug. Okay, so if you notice, I'm actually using the standard form right now. We're going to enter it. Zoom out a little. Let's zoom in to get the vertex. That's what's going to be important here. So our vertex, if you guys notice, is at negative 7. That's our minimum value. We've got that. And it's at negative 3 and negative 7. And this is probably stretched by a factor of 2. Let's see. When I go over 1. Oh, sorry. This is over 1. Let's let that go away. My fault. Sorry, let's do that again. We have our minimum value. We know it's at negative 3 and negative 7. And when we go over 1, we're going up 2. So we know we've been stretched by a factor of 2. Example 3. Alex rents out snowboards at $12 a snowboard. She averages 36 rentals a day. Oops. 36 rentals a day. She discovers that for each decrease of 50 cents, she gets 2 more rentals. Okay? At what price can Alex maximize revenue? So we're going to let R equal total revenue. R equals total revenue. And X represents the number of increases. Or sorry, decreases in price. Total revenue. X is number of decreases in price. So we may find out that if she decreases her price 5 times by 50 cents, she'll max revenue. We're trying to discover that out now. So what I first of all need to do is I need to make an equation. Revenue is going to be equal to the $12 she starts at minus each 50 cents deduction. Or, sorry, I should say this is price times sales. I should have put that first. Revenue is equal to price times sales. Okay, so the amount of money you get as a business depends on how many of something you sell and what the price is. So if my price is $10 and I sell 5 items, I get $50. What we're doing is we're breaking price down. Her price is $12 to start, but it's going to decrease by 50 cents and maybe a number of times. Their sales start at 36, and the sales are going to increase by 2 for every price change. X is our price change. So what I've done now is I've set this up. This actually looks like it's in factored form. The The problem is I need to put this into standard form in order to change it into vertex form. There's quite a bit we got to do here. So I'm going to expand and simplify to turn this into standard form. So that means I'm going to multiply my first terms, which is 12 times 36. Yep. That gives us 432. We're going to take negative, so first terms, outside terms, sorry, 12 times 2x, that's going to give us 24x. Negative 0.5x times 36, so negative 0.5 times 36 is negative 18x. That was those. What did I just do first? Last terms. Inside terms and last terms. Here we go. Sorry. That will give us negative x squared. Negative 0.5x times 2 gives us negative x squared. I'm going to collect my like terms, so we get 432 plus 6x minus x squared. And finally, I need to rearrange this to put it in standard form. So we should have r is equal to negative x squared plus 6x plus 432. If you guys notice, we are now in our standard form. Now that we're in standard form, we can work on completing the square. So I'm going to take this equation I'm going to work with it on the next page. So we're in our standard form, and we need to maximize revenue. In other words, we need to find the vertex of this parabola. Okay? So we're in standard form. We're going to divide the first two terms by the factor of a, whatever that is. In this case, it's negative 1. So we're going to divide each of these by negative 1. And in our brackets, we're going to be left with, we have negative 1 on the outside, x squared minus 6x. Negative 6x now becomes our b term when we go to put it into our side calculation. Remember, our side calculation for creating a perfect square is we take the b term, which is negative 6, divided by 2, and then square it. Negative 6 divided by 2 is negative 3. Squared gives us 9. And remember, we need to add and subtract the value of 9 inside those brackets. So our next line reads negative 1, x squared minus 6x plus 9 minus 9 plus 432. Remember, the negative needs to come to the outside, and when I take it to the outside, it needs to be multiplied by the front term, the term we factored out, which is negative 1. So I now have negative 1, x squared minus 6x plus 9. When we multiply negative 1 times negative 9, we get positive 9 plus 432. That means I'm just going to simplify our outside terms. Squared minus 6x plus 9. 432 plus 9 is 441. Now I need to factor my perfect square trinomial. The whole point of this was to create this. The shortcut to factoring it is we square root the first and the last terms. So we'll do a little side calculation for those. Square root of x squared is x. Square root of 9 is 3. So in our vertex form, which we should now be in, is negative 1. We put x and 3 as our terms. Now, because the term is a negative in front of our 6x, we bring a negative down. We square it, and we add 441. We're now in vertex form. So, because we're in vertex form, I now have an A value, which is -1, an H value, which is -3, and a K value, which is 441. So, as a rough sketch, we're going to do a rough sketch of this now. We'll get a graph up. All right, so let's take a look at this now. Our vertex form, we know that our vertex is going to be at 3 and 441. So we move over 3, and we're going to say maybe this is 440. Give it a nice round number. Here's our 3. So we're going to have, this is a rough sketch, some parabola that is facing downwards and goes like this. The reason it faces downwards is because our A value is -1. Okay? So we know we have a parabola that looks like this. This is going to be a max value now. So this is where they would maximize revenue. They would sell the most. And that would be if they were to make 3 decreases in price. Our X value, we decided was +3. And 441 ended up being our new revenue. So their revenue would increase to $441 if they make 3 decreases in price. So we actually have to figure out what the new price is going to be and how much they're going to sell. This is a way we can check this. We know that from our original formula, revenue was equal to 12, subtract 0.5x, 36 plus 2x. Our x value is 3, we discovered, for our vertex. So we're going to plug that in for both of these x values. We're going to get 12, subtract 0.5 times 3. This is how I check to see my new price. And 36 plus 2 times 3. Our new price is going to be 0.5 times 3, which is 1.5. So 12 subtract 1.5 is 10.5. So the new price is $10.50. Remember, this is price times sales. And the new amount of sales they'll make is 36 plus 6, 42. She'll now average 42 rentals. Did I put the right number in there? Oh, I think I did. So the new revenue, just to double check, is 10.5 times 42. It's $441, which is exactly our K value. So if their new revenue will be $441. If they decrease the price to $10.50, they'll end up selling 42 snowboards every time. And what we're going to do is I'm going to put all of the forms we had together. I'm going to show you how they came together on a graph. Gentlemen, this is really important. If you guys notice, we actually went through 3 different styles here. This was our factored form. This was our standard. And then this was our vertex. So we actually started in factored. We changed it to standard. And then from standard, we changed it to vertex. These all represent the exact same parabola. We're going to plug all 3 of these equations into our grapher just to prove this. So we've plotted our first form, which is our factored form. We're just going to quickly zoom in a little on the vertex. And we discover that our vertex is at 3 and 441, which is exactly what we found in our factored form. This right now, we are in our factored form. We found that with our vertex form. We're going to plug in the other 2 equations to see if we get the exact same thing. Okay, we're going to plug in our next one. And just to give you guys a heads up with this grapher, what will happen, we're going to zoom out, is if it's the exact same equation, you'll really see no change. So we pushed enter, we ended up with the exact same equation, and finally our last equation, which in vertex form was -1 x minus 3 squared plus 441. We push it again. Is this right? We got the exact same. So all three of those represent the exact same parabola.